Hi, I'm Hugh. I am a, oh, is that going to work now? Cool, there we go. It's kind of working. Hi, I'm Hugh. I am a developer advocate at Imply. We are a company that makes a real-time streaming database based on the open source project Apache Druid, which is actually a project that's run by the founders of the company and has been for 10 plus years. And we have Imply Hybrid and Imply Enterprise, which are based on that. I am outside of work. I like to make stuff. I'm a community organizer, and I'm an organizer at the AI and Deep Learning for Enterprise Meetup in London. So, as I said before, Druid is a real-time database. And what does that mean? Druid is used to answer questions like, what's the average temperature in every hotel room in a chain of a hotel? What's the most watched clip on like Netflix in the entire world at this exact second? You know, what server in a data center out of thousands is like too hot? Druid gives you the ability to ask the question like, what's happening right now, and get an answer immediately with that real-time time frame of like less than a second. When talking about what makes Apache Druid special, we can talk about its architecture and its parallelism and its treatment of data. So Apache Druid has a shared nothing microservices architecture, which is a bit buzzwordy, but what that boils down to is Apache Druid is built out of a bunch of unique components that you can compose to do whatever you want. So if you need more storage, you scale those up. If you need more compute, you scale those up. If you lose one component, you can replace it. You don't lose any data because everything goes into an underlying storage layer, which is completely separate from the cache you actually use to run queries. So Druid is highly customizable and very resilient. That architecture also affords a lot of parallelism. So because it's made of all of these different components, you can break up your queries with one component called a broker and fan it out to all of these separate services, which will give you a response back very quickly. So if you have a query that spans lots of periods of time, it gets broken up into a bunch of smaller queries that get sent to individual components. So it's very, very fast in that sense. Finally, with regards to treatment of data, so Druid is what's called an OLAP database. OLAP is a really bad acronym because it stands for Online Analytical Processing, go figure, which basically means it's a real-time database which is geared up for analytics first rather than transactions. So Aerospike make an absolutely incredible database which is more geared up for transactional processing, as I understand it. So that would be what would be called OLTP, which is Online Transactional Processing. Again, not an acronym, but that's just the ones that we use, I guess. So what am I here to talk to you about today other than what Apache Druid is? So I started as a developer advocate at Imply about 6 months ago. I'd worked a lot with databases before. I've worked for retailers in the UK doing real-time data there, but I'd never worked with Apache Druid specifically. And because I like to make things, I decided that I wanted to build some dashboards in Grafana and play around with some data to really get a sense of how Apache Druid works and what makes it tick. So today I'm going to be talking to you about, I just realized I'm kind of off camera here. Today I'm going to be talking to you a bit about what I built and how I went about learning about Apache Druid and how that kind of can give you a view of all the cool things that Apache Druid does. So I needed some data to do that. The thing about a database like Apache Druid is that it's designed for tens of gigabytes of data every day, every second, every minute, you know, that kind of thing. If you're just doing a kind of a simple like sign-in API or something, it's the wrong database for you. So we needed a lot of data to play around with this. So what the team and I are doing is running a bunch of receivers that track aircraft and collect data from those aircraft so that we can build this big data set and use it for experiments and for demos and stuff like that. And the way we're doing that is with receivers like the one over there on my right. You may be looking at the bundle of wires and the antenna and be like, what's that over there? I'm not war driving Wi-Fi passwords. It's tracking aircraft, I promise. And it's tracking them using something called ADS-B. So ADS-B is the Automatic Detection and Surveillance Broadcast Protocol, which is a bit of a mouthful, but essentially it's just what aircraft use to communicate with other aircraft and with air traffic control, their position, speed, and bearing at all times, as well as some other information. This is all completely open. Anyone can see it, which is quite important when you think about it, because you don't want two planes not knowing where they are at any given time. So it's all publicly available. So with kit like this, we can collect all of it and use it to do experiments, like I say. So here's how that works. The receivers look like something in the top left, or that one over there. That's actually the same one. Each of the receivers has a Raspberry Pi and an antenna. On the Raspberry Pi, we're running some software called Flight Radar 24. So some people may be familiar with Flight Radar 24, but they are a website where you can go and track aircraft, right? Like if you're taking a flight and you want to show someone where you are, you can send them a Flight Radar 24 link. And the way they do that is that members of the public collect data and send it to them, as well as some kind of supplementary satellite feed stuff. So we're running that software and we're uploading the data to their dashboard. And I hope I can, oh, that's not what I wanted to do. I can show you. There we go, perfect. So that receiver over there, despite the fact that it's in a building, it's doing its best and it's tracking, oh, yeah, 3, 4, 5 aircraft over Barcelona, which is pretty cool. But this is their website and this is where all the data is ending up. But what we're doing for this demo is we're intercepting that data before we send it and diverting off onto our own Kafka topic. So if I jump back to my slides, you can see the way that we're doing this is we're using KCat or KafkaCat, which is just a really neat tool for writing data into Kafka topics. We're using that to send all of this data to Confluent, to an Apache Kafka topic in Confluent, and then we're using ksqldb to just change the format of that. The reason we're doing that is just to get it into JSON because it makes everything else a little bit easier. You can write into Druid as CSV, but this just made other things that people were doing at the time a bit easier. This demo used to have Flink in it, but we won't talk about that. Apache Druid is doing all the heavy lifting. So it's the storage layer and the querying layer. So all of our data from all of these receivers is ingested into Druid, and then Druid also provides the compute engine, the querying engine for going and answering all the questions that you want over that data. Finally, I'm using Grafana to build some dashboards and some visualizations to have like a look at this data and to find patterns and things like that. Everything to the right of this line here, so everything over on this side, is running on my laptop. So you can run Druid at really small scales. You can run it at petabyte scales if you're like, you know, a huge company, but if you just want to play around with this and experiment, then you don't need like serious hardware or like a bunch of AWS resources or something. So Apache Druid works really well with streaming. Apache Druid was originally designed with like ad tech use cases in mind. So it's really good at things like sessionization and working with lots of seemingly like disconnected or unrelated data and bringing it all together to find like meaningful insights. The ways in which Apache Druid works really well with streaming are as follows. So you can connect really quickly. It's really easy to get data from Kafka into Druid. You can do transforms and filters. So you can process your data and do some kind of ELT stuff in Druid, although it's worth noting again, because Druid is optimized for analytics, you want to do that on ingestion and not having lots of transactions and changing your data once you've brought it in. Druid is optimized for OLAP. So there's a bunch of stuff that you can do to data as a data scientist or as a data engineer to get really performant queries. Druid's going to do a whole bunch of that out of the box for you. There's a bunch of clever stuff around indexes that will mean that your data is going to be super fast to query before you even start thinking about your data model. Druid has unified fast querying. So one of the problems with running a real-time database is you have all of this data coming in and you have all of this historic data and you want to query it all at the same time. Druid does that in a very clever way by, let's do that. Druid does this in a very clever way by allowing you to query from the tasks that do ingestion, so bring in data from real-time streaming sources and from historical sources at the same time as part of the same query. So that means that you send one query and you get your old data and your new data in the same response, as long as it's relevant. Druid will help you stay optimized. So Druid does a bunch of stuff, again, out of the box to help keep your data as optimized as possible, but also offers a bunch of services, including compaction, so you can go back and reformat your data to keep it as efficient as possible when querying. Finally, Druid offers backfill and update. So whilst again, it's not optimized for transactions, you could go and replace whole sections of data wholesale in the background without impacting query or ingestion performance if you're going and doing things like disaster recovery or you're removing old data or something like that. And you can process offline. So there's a whole separate API called MSQ that you can use with Druid that lets you do a bunch of clever stuff around going and changing your data or reformatting or reprocessing, which runs on entirely separate processes. So you can have all of that running in the background without impacting your cluster, doing a bunch of stuff to that data. So now that we've had kind of a high-level overview of all the different things that Druid does with streaming, let's look at one in particular, which is ingestion. So jumping over to my first Grafana dashboard, actually, can everyone see that okay? Or is that kind of invisible at this scale? Does that look okay? Cool, people are nodding, good. Cool. So here's one of the things that I did with this data. So over here, we have this heat map of all of the receivers, apart from that one, that the team and I are running, that take the longitude and latitude of an aircraft as it's tracked within the time period, which is the last 24 hours, and plots it on this map. So far, not so real time, but it does let us start looking at the kind of shape of this data. We also have some metrics over here on the right that I'll talk more about in a bit. But you can see the top one there that's kind of hidden by me is the total unique aircraft tracked in the period. And then we have the average horizontal distance and shortest horizontal distance to those aircraft. So to actually get this data in and start doing these visualizations with it, I can jump over to Druid, and you can see the web console. So you can do everything that you can do with Druid programmatically with the programming language of your choice. We have a bunch of APIs and things like that. But if you're doing things from the console, loading data is as simple as going to load data, going to streaming, and then there's a whole streaming spec wizard. Let's say I'm streaming from Kafka. And then, if I just move this out of the way, it's really as simple as just plugging in the details of your Bootstrap server and any auth that you're going to be doing. So it's super quick and easy. I already have a streaming job running for this demo. If I go to data sources, you can see I have this ADSB JSON data source, which is basically a kind of overview table of all of this data. And then you can see the supervisor, which is the process that's responsible for managing all the tasks that do the ingestion, and then the actual tasks themselves, and then finally the segments where all that data ends up. And that kind of like process that looks after processes is a product of that distributed architecture of all those different components where one process manages multiple others. So you have a kind of a tiered system. So you've seen that it's really easy to get data in, but once we've got it in, how do we actually do stuff with it? So transforming and filtering is really useful. And to build this demo, I had to use it quite a lot to make things work. Because this is what ADSB data looks like, raw. So you'll see it's really sparse. You'll see in some of these places, there are like a bunch of commas with no data in between them. So that's a blank field. And that's because in the ADSB protocol, there are like 6 or 7 different types of messages, and each of them contains different information. So if you're trying to make a heat map and plot aircraft longitude and latitude, you want the ones down here that have these longitudes and latitudes in, but you don't really care about all the other ones. It's also very repetitive. Aircraft are just like yelling into radio all the time. They're flying overhead and they're sending like 50 messages a second, up to 50 messages a second in ADSB. So there's a lot of stuff in here that we don't really need. Coming back again to our heat map example, you don't want to plot the same point like 1,000 times each for, like fractions of a second, right? That's not useful data. And also, finally, it has low value dimensions. So for what we're doing here, we don't necessarily want to know if there's an emergency on board the aircraft, which is one of the things that's included in the ADSB protocol. And we don't necessarily want to know all these different numbers at the start, which are just different ways of identifying an aircraft. So I used transforming and filtering in Druid to remove and reduce some of these values. So we can use data rollup, which is essentially a group by an ingestion time, to group together all of those 50 different messages from the aircraft in under a second into 1 or 2 messages. So we're still real time, but we're a little bit less real time than we were before. So we don't have all of these messages we don't need. I'm also using a explicitly defined schema to remove the columns that aren't needed for the dashboards I'm building. So by default, Druid sees your headers in your Kafka topic and converts all of that into a table automatically. But if you don't need those columns, you can define the schema and remove them. So you reduce the total size of your table, which is going to make everything a lot more performant because the less data you're querying, the less time it's going to take for those queries to complete. But this isn't just a subtractive process. We can actually do some interesting stuff with transforms as well. So earlier when we looked at that first dashboard, we had these values over on the right. So as I mentioned before, Druid does a bunch of stuff for you to make your query super fast. So this value at the top, total unique aircraft by time period, is a count. So Druid will create this kind of metadata when you ingest your data with things like maximums and minimums all pre-calculated, so that when you query this, instead of going and doing the math, it just goes, oh, yep, here's your answer based on live data. You don't lose any precision or accuracy from this, and it means that you have your answer right away. But these ones down the bottom, average horizontal distance to aircraft and shortest horizontal distance to aircraft, aren't quite as trivial. So to get this value, you actually have to measure the distance on like the curvature of the globe or something like that. The maths is initially kind of baffling. I was like, oh, right, I'm going to look up this formula and move things around. There's lots of like trigonometry in there, but you can make it work. But the problem then is that even though that's quite a simple equation to do, you don't want to do it for thousands of aircraft each time for each receiver. And then also on top of that, I want to do these aggregations for things like the average and the minimum distance. So the way that I'm doing that here and still getting these answers back really quickly is using transforms. So I have a transform that takes that equation, and when the data comes into Druid, calculates that answer for that time period. So I can go and look at any time period where I have data, and I'll have all of these values pre-calculated. So you can do that for all kinds of things, but here I'm just doing it for these distances. But again, that saves you time at query because you aren't having to calculate these values every time and use compute to do that. So that's actually, so I missed a bit of my slides. This is why it sucks I don't have my notes. But the reason why I thought of doing the nearest distance to the aircraft is because of the little factoid you hear a lot, which is that you're never more than 5 meters from a rat in London, which I mean, you'd have to go out and calculate rat population density to figure that out, I guess. But you know how far away you are from a plane if you have this data set exactly to the centimeter if you really want to. Okay, so we've looked at doing transform and filtering, and we've looked at optimizing for OLAP. Let's look at how you can stay optimized. And I'm moving, let's look at how you can stay optimized. So that is using compaction, which I mentioned before. Compaction is really clever because effectively what it lets you do is re-ingest the data in your segments and combine them into new segments. It lets you do all the transforms and filterings that you would otherwise have done on ingestion and all of that, but it just lets you run it in the background. So the way I'm running it here is that it's on all data older than 24 hours. So we have our real-time segments down here that won't be affected. So we aren't messing with any of our real-time data. But I can do things and go back, for example, where right now I'm aggregated down to like 1 second. I could go back and aggregate to 15 seconds or a day or something for the data where I don't need that level of precision, but I still want to store the data for records and stuff like that. So you can see how that would be useful for things like financial transaction data or that kind of thing. Or in this aircraft example, if I'm an airline, I really care about where all my planes are when they're in the air. I care less when they were in the air 6 months ago. So compaction is really easy to set up. You just go to data sources and you enable it and you put any config that you want. You would see that some of these segments would be around 5 million rows, but I forgot to turn on compaction until I got here today, so it's not had a chance to run yet. But compaction, one final benefit of it is that having your segments around 5 million rows means that you don't spend lots of time at query searching in a bunch of different files because all these segments are ultimately like their own little database file in a proprietary format. And it means that you don't end up with one enormous segment that takes forever to search through. So it means that it's that focus on OLAP, it's making your queries and your analytical use cases as fast as is possible. Moving swiftly on because I know I'm a little over time here. Okay. So finally, let's talk about querying, which is the whole reason you use an OLAP database is because you care about querying. So far, we've just been looking at this data for the last 24 hours, so not super real time. But if I jump back to one final dashboard, I get to individual flight view. Cool, there we go. So here we have this kind of view from the cockpit. So we can see where an aircraft is live in real time, granted, as live as a Raspberry Pi with a tiny antenna can figure out. So right now we can see an aircraft that's over Germany. We know the altitude, the speed, and the heading. We can see the squawk, which is a really easy way of identifying aircraft from aircraft databases. And we can see which receiver is tracking it. So my colleague Helmar is tracking this one. And again, this is at all real time in that kind of sub-second latency. And we can jump through and we have a look at a few different ones of these. Helm tracking a whole bunch, it looks like. There we go. This one is an incomplete ADS-B message, which even with all the Druid stuff in the world, you can't deal with ADS-B data being kind of messy. Delightfully, my colleague Kyle in Cornwall called his receiver Beanhead. So that's in the data forever. Thanks, Kyle. But there you go. So you can query super fast. And again, we can look at that view for all of those aircraft and see their position, their speed, their heading, and all of that for thousands and thousands of aircraft and have that all live in real time and have them updating and see it move without having any performance impacts. And you can scale and scale that system as much as you need to. So one final thing. So we've been talking about Druid through the lens of this demo a lot, through kind of playing around and building stuff and experimenting with data to see what we can do with Druid. But I think it's worth drawing attention to how Druid is actually being used in the real world. So Netflix use Druid for their observability and their analytics tooling. So in this demo, there are like 6 of these receivers in the world producing data into the Kafka topics and into Druid. And there's a handful of consuming tasks running at any given time on my laptop, bringing in that data. At Netflix, they have millions of both producers and consumers, which produces a huge amount of data. Druid is able to scale to meet those demands by adding nodes and adding processes to deal with petabyte scale data, to both give this really fast observability view where you can see how all of your systems and processes are doing all the time, and also to give you a bunch of data about deployments as they're going on, and also the users. So earlier on in this demo, I gave the example of you can use Druid to ask the question, what's the most watched show on Netflix? And I say that because that is what they use to figure out what the most watched show on Netflix is. So yeah, you can see that Druid is out there in the real world being used for these internet scale problems. So I think that's about a wrap. So that gives you a view of all of the different things that you can do with Apache Druid to power your real-time use cases, whether it's connecting quickly or staying optimized or filtering. If you're interested in hearing a little bit more about backfill and update and processing offline data, you can check out our courses at learn.imply.io, where we have a bunch of other stuff about Apache Druid basics and all the cool stuff you can do with open source Druid. You don't have to pay for anything. If you do want to pay for something, the sales team would kick me for not saying, look, we also have Polaris, which is our SaaS product, where you can go and use Druid without having to do any of the stuff I've talked about in terms of scaling or provisioning. You can just go and use it as is. And also we have a fantastic podcast run by my colleague Rena, Tales at Scale, which is all about what people in the real-time ecosystem are doing. So it's not just Druid. If you want to go hear about how Apple or Netflix run their real-time stuff, then you should definitely check it out. I will leave it up there for a second if anyone's jumping for QR codes, but it looks like we're all good. Cool. And one final thing that I would be remiss not to mention is that next month in San Francisco, it's Druid Summit. So if you're a Druid user and you happen to be in San Francisco, or I don't know, then please do check it out. It's the main event for Druid in the year. We'll have lots of really exciting panels and talks from people. So if that's of interest, please do go to the Druid Summit website and take a look. That's all from me. Thank you for listening.